Here's a word for you, conjugate. So what's a conjugate? Well, conjugate basically is a really large term, I suppose, for something very simple. When we saw the binomials, root 3 plus root 2, something like that, two terms, so we call it a binomial. If we get the same terms except different sign, so whether it's a plus to a minus or a minus to a plus, that's what we call a conjugate. So the conjugate of root 3 plus root 2, root 3 plus root 2 is root 3 minus root 2. So if they got the same different signs, they're conjugates. So root 2 plus root 5, the conjugate's root 2 minus root 5. 3 minus root 7 gives us 3 plus root, the conjugate is root 3 plus root 7. And 3 root 2 plus 4 root 3, the conjugate would be 3 root 2 minus. So see how we're just changing the sign. Why do we bother with conjugates? Well, we get a nice result when we multiply a conjugate with itself. So if we use the idea of using just the algebra here, a plus b and a minus b, those two are conjugates. When we multiply these out, so we multiplied out like we were doing before, the a times the a would give us a squared. A times minus b gives us minus ab. Then we get b times positive a gives us a positive ab, and a b times a minus b gives us minus b squared. Now if we collect our like terms, the a minus ab and ab, they'll cancel each other out. They go. So that's nice in that respect, because all we're left with is a squared minus b squared. What we call this is a little rule called the difference of two squares. Two squares there, because what happens is that when we expand these brackets out, that's what we get. We get the difference of a square number and a square number, which is very nice with surds, because what happens if you have a look here, root 5 plus root 3 root 2 times root 5 minus 3 root 2, what we're going to do is bring this down. Shorthand way to do it would be say, we'll take the first term, root 5, square it, minus the 3 root 2, all squared. Now what happens when we square a square root is that the square root goes. So that becomes 5. 3 root 2 would be 9 times 2, which gives us 18. 5 minus 18 gives us minus 13. So what we've done is, when we take multiply a surd by its conjugate, we end up with a rational number, because it starts to rationalize, because we're squaring it all. So we get a rational number in there. You can check it out with this example as well. 5 root 3 minus 2 root 7, 5 root 3 plus 2 root 7. So again, we've got a situation like we have up here. So we take our first term and square it. So 5 root 3 all squared. So that'd be 25 times 3 root square root of 3 times square root of 3, which is 3. 3 25s is 75. Minus 2 squared, which is 4, times root 7 all squared, which would be 7. 4 times 7 is 28. Simplify it down to 47. So that's what we're looking at for a conjugate. Conjugates are really nice, and we're going to use them later on in what we call rationalizing a denominator. We're going to play around with fractions, with surds, and try and rationalize a denominator. To do that, we need a way to get a rational number. Here's a way to get a rational number, is multiply a surd by itself, and that's why we have all these rules with our conjugates and all these applications with a conjugate to get a rational number from that multiplication.